We're going to be talking about phase shift oscillators. The group is comprised of Areeb, Justin, Nezar, and Shady. So just some background information just to familiarize yourself about what an oscillator is, what sets a phase shift oscillator from other kinds of oscillators, a little about the history, and just some uses.
To start off, we'll talk about what an oscillator is. An oscillator is an electronic circuit that produces a periodic oscillating electronic wave, usually being a sine wave or a square wave. An RC oscillator is comprised of the RC network, a combination of resistors and capacitors, and an op-amp. In this picture, you can see the result of an oscillator.
So now that you have a general idea of what an oscillator is, this tree shows you how different kinds of oscillators are categorized and where phase shift oscillators fall into this. So just starting off with basic electronic oscillators, those can break down into linear harmonic oscillators or nonlinear relaxation oscillators. Linear harmonic oscillators produce sinusoidal outputs, and then those can break down into feedbacks and negative resistance oscillators. We're going to focus on feedback oscillators, and those can be like transistors or op amps, and they're usually connected in feedback loops, so just like the picture on the left. And finally, those break down into three different kinds of oscillators, where we have RC, LC, and crystal oscillators. And phase shift oscillators fall under the RC categorization. So they're just a network of resistors and capacitors, and they're usually used to generate low frequency, so around the audio range.
So let's look at a brief history of oscillators. One of the first electronic oscillators was an oscillating arc by Elihu Thomson in 1892. The vacuum tube feedback oscillator was invented around 1912 when it was discovered that feedback could produce oscillations. A couple of years later, the first and most widely used relaxation oscillator circuit, the astable mitral vibrator, was invented in 1917. Only 3 years later, the vacuum tube feedback oscillators became the basis of radio transmissions by 1920, and the mathematical conditions for feedback oscillations were derived in 1921. In 1969, Kurokawa derived necessary and sufficient conditions for oscillation in negative resistance circuits, which form the basis of modern microwave oscillator design. Some of the uses of RC oscillators include the conversion of DC current to AC current. They are also mostly used to generate lower frequencies, for example, in the audio range. Some of the frequent uses of RC oscillators are in phase shift oscillators, twin T oscillators, and Wien bridge oscillators.
So now that you have some idea of what an oscillator is, let's get a little technical.
So these are the components for the oscillator that we are making. So it consists of a 741 op amp, one 1.2 kilo ohm resistor, two 1 kilo ohm resistors, and one 35 kilo ohm resistor. It also includes three 0.01 microfarad capacitors and a 15 volt power source in order to power the op amp. So how it works generally is that, so the op amp is set up as an inverting op amp due to the feedback through the 35 kilo ohm resistor, and this provides a phase shift of 180 degrees. And the feedback from the RC sections also adds another phase shift of 180 degrees. So the feedback loop has an attenuation of 1 over 29, so the gain from the inverting op amp needs a gain of 29 to keep the loop gain as unity, essentially in order to keep the gain as 1. So the more RC sections there are, the higher the phase change rate, which increases frequency stability. Each RC section provides 180 over n degree phase shift, where n is the number of RC sections. And this picture here shows the output from the circuit from Multisim. So that's the end of our presentation. Thank you for watching. Hopefully you learned something.